section 9.2, which goes over the sum and difference identities for the trig functions, right? So if you look at the second page of the cheat sheet, we have the sum and difference formulas. It's on the right column here, right? So the sum and difference formulas, and we have the three trig functions: sine, cosine, and tangent. But in actuality, for each trig function, there are two different formulas, right? So the sum formula and then the difference formula. That's what this plus or minus in the formula is indicating, right? So the plus is for the sum formula and the minus is for the difference formula. So in actuality, to save space, there are actually six different formulas here, right? So sine and then plus and then sine and minus and then cosine and plus and cosine and minus and so on and so forth, right? So they're using a sort of shorthand notation. So how do you actually read off the formula here, right? So you want to be careful because here you have plus and minus, here you have plus minus, here you have plus minus. But if you look here, this is actually, it's upside down, right? It's minus plus. And so the two things are actually slightly different, right? So the way you read the formula is that if you're using the sine sum formula, right? So this is alpha plus beta, then this needs to be a plus here, right? So if using the sign on the top here, you need to use the sign on top here, right? So if you want the cosine sum formula, it's a cosine alpha plus beta, because the sum is on top, the sign on top here is the minus, right? So the formula for cosine of alpha plus beta is actually cosine alpha cosine beta minus sine alpha sine beta, and then cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Right? So be careful about the whether you have a plus or a minus when using these formulas. Okay, so that's what I mentioned here, right? So be careful of the plus minus versus the minus plus, where the cosine formula should read like this. Okay, so how are we going to apply the sum and difference identities, right? So we're gonna deal with mostly with angles that are not actually the given special angles, right? So 75 degrees itself doesn't appear on the unit circle, but even though these are not the special angles, we can calculate exact values. Right, so we can calculate exact values by relating them to special angles, right? So the way we do it is to express the given angle as either a sum or difference of two special angles, right? So express the angle theta, right? So like, for example, here theta is 75 degrees, and write it as a sum of or difference of two special angles. And typically there's more than one way to do it, right? So so here theta is 75 degrees, right? So I can write theta is alpha plus beta, right? So 75 degrees is, I can think of as 30 degrees plus 45 degrees, right? And these two are special angles. Or I can do, say, theta equals alpha minus beta, and I can think of 75 degrees as, let's see, so 75 degrees I can do as 120 minus 45. Right, so typically there's more than one way to represent these angles, and you can choose whichever way you want to do it. Okay, so let's just do it. Let's just do it this way. Right, so 75 is 30 plus 45. Right, so I do cosine of 30 degrees plus 45 degrees. Right, but what is, so I need to use the sum formula for cosine, which is exactly this, right? So cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Right, so if you look at the formula sheet again, we're using cosine alpha minus beta. Right, so the minus appears on the bottom, so I need the bottom symbol here, which is a plus, right? So cosine alpha cosine beta plus sine alpha sine beta. Okay, so again, this alpha is 30 and then beta is 45. So this is alpha, this is beta, so I just separate them. Okay, so this is cosine 30 cosine 45 degrees minus sine 30 sine 45 degrees. And then each of these is a special angle value, so I can just get them all from the unit circle, right? So what is cosine 30? Cosine 30 is square root of 3 over 2. Then what is cosine 45? Cosine 45 is square root of 2 over 2. Sine 30 is 1/2. And then sine of 45 degrees is square root of 2 over 2. Okay, so now we can just calculate this, right? So multiplying fractions, just multiply straight across, right? So square root of 3 times square root of 2 gives you square root of 6. 2 times 2 is 4. And then 1 times square root of 2 is square root of 2. 2 times 2 is 4. Okay. So this is my solution. Okay, so the basic idea again is to represent the given angle as the sum or the difference of two special angles, and then apply the appropriate formula to get the values that you want.
Professor, can we go further?
No, no, you can't. You can't really go any. Can't simplify this any further. I mean, you can, because they have the same denominator. You can write it. You can write it like this: square root of 6 minus square root of 2 as a single fraction, like this. But you really can't really simplify it, and you can't combine the two radicals. At least if you want to give the answer as an exact value, right? Otherwise, you would just put into a calculator and get an approximate answer. Okay, and any other questions on this problem? Okay, so the other two examples are similar, right? So this is theta, right? So I mean, for each of these, you can also you can always do it both as a sum and a difference, and there's also multiple choices of which angles to use. So again, if say I want to do a sum, right? So I can do 195 as so I need to pick out special angles. Right, so how can I do 195? Well, I can do 150 plus 45. But again, there's more than one way to do it, right? So instead of doing 150 plus 45, how else can I do it? I can do 60 and 135. Right, so so let's try it this way. So 160 plus 35. So let's write it out. Right, so I'm using a sum formula for sine. Okay, so sine alpha plus beta. So what is the sum formula for sine? So sine alpha plus beta. So plus is the symbol on top, so I need the one on top here, which is also a plus. So it's sine alpha cosine beta. Cosine beta plus cosine alpha sine beta. And I'm doing 60 and 135. Right, smaller. I'm running out of space here. Sine 60 plus 135. Right, so alpha is 60 and beta is 135. So I just write it out. Sine 60 cosine 135 plus cosine 60 sine 135. And okay, so now we just look up the values again on the unit circle. Right, so what do we have? So sine 60. Sine 60 is the y coordinate, so square root of 3 over 2. Cosine 135. Cosine is the x coordinate, so the x coordinate for 135 is negative square root of 2 over 2. And cosine 60. Cosine 60 is the x coordinate, is 1/2. Sine 135. Sine 135 is the y coordinate, so square root of 2 over 2. And then again, we can multiply the two things. So this is minus square root of 6 over 4. And this is plus square root of 2 over 2.
Should be 4, right? Root 2
Oh, yeah,
by 4.
yeah, you're right. Square root 2 times 2 is 4. 2 times 2 is 4. Or if you prefer as a single fraction, you can always write as minus square root of 6 plus square root of 2 over 4. Okay, so any other questions on this example? Okay, so example C is again similar, but now let's try to do it as a difference instead of a sum. But again, it doesn't really matter which way we do it. Okay, so 105. Let's try to do it as a difference. So 105. I can do it as 135 minus 30. Okay. So this is alpha, this is beta, and we're using the difference formula for cosine. So cosine alpha minus beta. So cosine alpha minus beta is this one here. Right, so cosine alpha, cosine beta minus sine alpha, sine beta. So let's just write it out, right? So cosine 135, or yeah, 135 minus 30 is cosine 135 cosine 30 minus sine 135 sine 30. And okay, so I'm just gonna calculate them real quick. So cosine 135 should be negative square root of 2 over 2. Cosine 30 is square root of 3 over 2. And then sine 135 is positive square root of 2 over 2. And then sine 30 is 1/2. So I get minus square root of 6 over 4 minus square root of 2 over 4. Okay. So that's what we get. Actually, for this example, let's do it in 2 different ways, and you'll see that it doesn't matter how you do it. You get the same answer either way, right? So let's instead do let's instead do 105 is equal to 60 plus 45. Right, so then cosine 60 plus 45. I don't have so much space here, so let's just write it out. Right, so it's the sum form for cosine. Right, so it's going to be this one here. So you have cosine 60 cosine 45 minus, right, so the form for cosine is the opposite, right? So when, oh, I messed something up, right? So what was the difference form for cosine? the difference formula for cosine has a plus sign here. Right, so this should have been a plus here. Makes this a plus, and this a plus. Right, so yeah, so that's what you want to be careful about with the formula for cosine, right? So the sum formula for cosine has a minus here, and the difference formula for cosine has a plus here. So this now should be the sum formula has a minus here, right? So this should be a minus. Okay. So now it's correct. Okay, so this is sine 60, sine 45. So what is cosine 60? That's 1/2. Cosine 45 is square root of 2 over 2. Sine 60 is square root of 3 over 2. Sine 45 is square root of 2 over 2. So you get square root of 2 over 2 minus square root of 6 over 2. Right, so they're the same. So it's just in a different order. Right, so the minus square root of 6 over 4 is on the left, and here it's on the right. But these are both the same.
Sir, you made a mistake. I mean, 2 into 2, 4, right?
Oh yeah, 4. 2 times 2 is 4. Or now they're before they weren't. Okay, so now they're the same. Yeah, so it doesn't really matter how you represent the angle, as long as you find two angles that you can work with, and then apply the correct formula. Okay, so and any questions on using the sum and difference formulas?